Today we did some problem solving involving probability. Problem number 3, I want to do that one with you. It's very similar to problem number 1. A farmer buys individual letters to make a sign saying no trespassing. On the way home, 3 of the letters fly out of the back of the farmer's pickup truck. What is the probability that the farmer lost all 3 S's? The confusing thing about this problem is it's hard to tell whether this is independent or dependent probability. And the easiest way for me to explain this is, even though all 3 letters may have flown out at exactly the same time, there's no such thing as exactly the same time, right? That one of the letters would have to fly out just a millisecond before the second letter. It's really a dependent probability problem, but you just have to reconcile the fact that all 3 S's are available for the first time that an S flies out, and then only 2 S's are available the second time an S flies out, and so you have to treat it as a dependent probability problem. So the probability for the first, really what we're trying to find here then is the probability of S, all 3 of the S's flying out. That's going to be equal to the probability of the first S flying out multiplied by the probability of the second S flying out multiplied by the probability of the third S flying out. The first S, the favorable outcomes would be 3 because there are 3 S's in the truck out of a total of how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 3/13ths probability for the first S to fly out of the truck. The probability that the second S will fly out of the truck is now 2 because there's only 2 S's remaining, and there are actually only 12 letters remaining now also because that S was one of the letters that's no longer in the truck. The third probability will be 1/11th for the same reason. There's only 1 remaining S, and there are now only 11 letters left in the truck. Then we can start to make our life easy by simplifying some things. 2/12 simplifies to 1/6, and then 3 and 6 both have a common factor of 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. All of our numerators are now 1s, so we're not going to be able to simplify any further. 13 doubled is 26. 26 multiplied by 11 is 260 plus 26, or 286. So 1/286th is the probability that all 3 of the letters would be, that all 3 S's would fly out of the back of the truck. The other problem I want to look at is problem number 7. In the spinners below, what symbol could be placed in this empty section so that if you spin each spinner once, the probability of spinning 2 hearts is 1/4? You may only use a heart, diamond, spade, or club to fill the space. Try that one on your own first during the pause, and then come back and compare your work to mine.
Paused.
We want the probability of heart, which will be equal to the probability of heart on the first spinner multiplied by the probability of heart on the second spinner. Probability of heart on the second spinner we can calculate because we know all the spaces on the second spinner. We have 1 of each suit on the second spinner, so that's 1/4 multiplied by, we don't know what, but we know we want the probability of spinning 2 hearts to be 1/4. So this must be 1. This can't be anything other than 1 if this overall probability is 1/4. We know we have 4 possible outcomes on the first spinner because there are 4 equal-sized spaces. I should say equal-angled spaces since it's a spinner. The spinner could land in any one of these 90-degree arcs. But what would the numerator need to be in order for this fraction or this probability to equal 1? Well, 1 means certain, so the only way it can be certain is if all 4 of the spaces are hearts. Then you would have 4/4, which would equal 1 whole, and 1 multiplied by 1/4 is 1/4. So the missing space must contain a heart. Okay, I hope that helped with the homework. I'll see you tomorrow.